Okay, this is hopefully the last video I'm going to do on this section. So, the cross-section of the drain shown below there is to be an isosceles trapezium with three sides of length 2 meters as it shows. Find the value of theta, which maximizes the cross-sectional area and hence the maximum area. So, there's not much which is actually given to you in this problem. What I would be suggesting is, again, we need to know our rules for different areas. And the area of a trapezium is half of the height multiplied by A plus B, where A and B are the parallel sides of the trapezium. So we know this side here. We also have a parallel side up there, which isn't actually part of the diagram, but we still need to know that length. So we know this is 2, but we don't know this bit here yet. We can figure that out. We know that, well, this section up from here to here is 2 meters. But we don't know this part out here, and we don't know this part out here. But luckily this diagram has a bit of symmetry to it. And, well, we can figure out what that is, because that distance there is going to be the same as this distance here. And this, luckily for us, is a right angle triangle. So, if we have 2 along there, remember that cos is the horizontal component and sine is the vertical component. So this distance here, just using a bit of SOHCAHTOA, okay, cos theta is the adjacent over the hypotenuse. That means that the adjacent is going to be equal to 2 times cos theta. So this distance right here is 2 cos theta. So that means we have 2 cos theta there, and we also have 2 cos theta there. That means that the full length is going to be 2 plus 4 cos theta, because we're adding on 2 off that 2 cos theta. So basically that means that the area then can be written as half of the height. Oh, gee, I didn't find out what the height was either. But the height can be found in much the same way as the other value. That's going to be just 2 sine theta. So half of 2 sine theta multiplied by A, I usually say is the shortest side there, which is just 2, plus B, which is 2 cos theta plus 2 cos theta, which is 2 plus 4 cos theta. And we just simplify that a little bit. So half of 2 sine theta is just sine theta out the front of 4 plus 4 cos theta. Well, that's looking pretty good so far. So the next thing, we want to find out what the maximum is going to be. So we need to get dA d theta. And because we've got a function multiplied by another function, we're going to be using the product rule. So I'll do this off on the side. I'll go u equals sine theta, and v equals 4 plus 4 cos theta. So du d theta is just cos theta, and dv d theta is going to be negative 4 sine theta. And we sub all that in. So u dv dx, which is sine theta multiplied by negative 4 sine theta, plus v du dx. I'm going to write it in the opposite order. It's going to be cos theta multiplied by 4 plus 4 cos theta. And expanding that out, making it look a little bit nicer, gives us negative 4 sine squared theta plus 4 cos theta, and then plus 4 cos squared theta. Right. So at the moment I have an equation in terms of both sine and cos, which isn't all that good to solve. So I'm thinking that we might need to do a bit more work on this still, and I'll come back to that in the next video.